Good morning to all. Today I will discuss about a course called Refrigeration and Air Conditioning. Before moving to the content under Refrigeration and Air Conditioning, let me introduce myself. I am Dr. V. Dhanaraju, working as an Associate Professor, Department of Mechanical Engineering, LVRC. The main objective of this course, Refrigeration and Air Conditioning, is to provide fundamentals of refrigeration, like what is refrigeration, methods of refrigeration, COP, turn of refrigeration, and the various cycles used in the refrigeration, like air refrigeration cycle, which may be reverse Carnot cycle, or actual refrigeration cycle, or bell column cycle, VCR cycle, VAR cycle. Apart from the cycle analysis, we need to estimate the performance parameter of refrigerator called COP, then capacity of the plant. Along with, we need to know the fundamentals required to understand air conditioning process. Those are called psychrometric process. Apart from psychrometry, we need to estimate cooling load design for the given system. That may be hospital, that may be auditorium or classroom, whatever it may be. How to estimate cooling load for the given thermal system. So these things will be addressed by this course. And moving to the content cover under refrigeration air conditioning, there are 5 units, where unit 1 provides introduction to refrigeration, where it gives the very basic fundamentals like what is refrigeration, then what is the need of refrigeration, COP, turn of refrigeration, methods of refrigeration. Then we need to discuss about air refrigeration system like bell column cycle. Then what are the different methods used in aircraft refrigeration system, followed with some fundamental problems related to the introduction of refrigeration. Those things will be addressed under unit 1. Coming to the unit 2, where we need to know about the most commonly used refrigeration method called as VCR, which stands for vapor compression refrigeration system, and VCR system components. So if you take any refrigerator, there are 4 fundamental components, namely compressor, condenser, expansion valve, and evaporator. So these things will be addressed with the help of suitable diagrams, and also we need to demonstrate how it will work and what are the merits, demerits. In the unit 2 itself, we are having a very small topic called as cryogenics. So what is cryogenics, what is the need of cryogenics, where we apply the cryogenic concept, those will be addressed under introduction to cryogenics. Then unit 3, in unit 3 we need to know about what is refrigerant, what are the reservoir properties of refrigerant, what are the different kinds of refrigerant used for various refrigeration and air conditioning systems, and how to designate a refrigerant. Those things will be addressed under refrigerant part. Then in the unit 3 itself, we are having another refrigeration method to maintain lower temperature called as vapor absorption refrigeration method. So how it will work, we will demonstrate. And another method used is steam jet refrigeration system. If you observe unit 1, unit 2, unit 3, all are relevant to refrigeration part. So in entire unit 1, unit 2, unit 3, we are focusing only one parameter called temperature, that is to be maintained lower than atmosphere. So how we are achieving lower temperature? So we need to go for different methods. Those things will be addressed under unit 2, unit 3, right? Then unit 4, unit 5 belongs to air conditioning. So in order to understand fundamentals of air conditioning, we require a concept called psychrometry. Psychrometry is a subject which deals with the behavior of moist air. The characteristics of atmospheric air is studied by a subject called as psychrometry. So we need to go for in detail regarding what is psychrometry, what are the psychrometric properties, psychrometric process which are essential to understand air conditioning system and its design. So those things will be covered under unit 4. And last, we are having air conditioning systems. It includes what is air conditioning system, what are the different types of air conditioning systems, like summer air conditioning, winter air conditioning, year-round air conditioning, central air conditioning system, unitary air conditioning. Those things will be discussed. Apart from this, we need to go for a design of cooling load systems. So we need to estimate cooling load for the given system. That may be a classroom, that may be auditorium, that may be cinema hall. whatever the thermal system is given, you need to estimate cooling load. Based on the cooling load, you need to go for size of the air conditioner in terms of capacity of air conditioner, maybe tons, right? So these are the different contents or modules covering under refrigeration and air conditioning. And what are the textbook? As per the given syllabus, so the preferred textbook is A Course in Refrigeration and Air Conditioning by Arora Dwamkundwar. This is the textbook you need to follow, where every content will be covered in simple way or simple understanding language. So I recommend this book for and another book is Refrigeration and Air Conditioning by C.P. Arora. So these two textbooks are given in the syllabus, and you can go for understanding the content beyond syllabus, like cryogenics. You need to go for Refrigeration and Air Conditioning by Manohar Prasad, where aircraft refrigeration system is completely given. Principles of refrigeration are dosed, where cryogenic concepts are included here. Basics refrigeration air conditioning, Ananta Narayan. So I recommend this one. It is sufficient to cover all the contents under refrigeration air conditioning. So apart from we need to follow one data book. So it is called Refrigerants and Psychromatic Properties by Mathur and Mehta. So this is data book is generally given in the end semester examination also. So you need to follow this data book, where it is essentially while studying about VCR system, VCR problems, similarly air conditioning design problems, psychrometry. So those things, this data book is very helpful. So this is the front page of the data book. So refrigerant and psychromatic properties by Mathur and Mehta. So you need to go for purchase of this data book. It is very helpful regarding unit 2 and unit 5. So today I will introduce the first unit of refrigeration and air conditioning. So these are the main topics under unit 1. So fundamentals. So what is refrigeration, necessity of refrigeration, COP, ton of refrigeration, and types of refrigeration systems. Then we are having air refrigeration systems. So what is air refrigeration system? What are the cycles that are used in air refrigeration system? There are two cycles. One is called theoretical cycle, called as reverse Carnot cycle, and the actual air refrigeration cycle as Bell column cycle. So we need to go for analysis with the help of PV and TS diagrams. Later we need to discuss about the open type and closed type air refrigeration cycle and actual aircraft refrigeration systems used in all aircrafts. So these are the important contents that are covered under unit 1. So let me define what is refrigeration, what is air conditioning, then we will go to the actual content. So refrigeration means it is a subject or a science which deals with maintaining lower temperature than outside. If you are able to maintain lower temperature than outside atmosphere, it is called refrigeration. So in the entire refrigeration process, we are controlling one parameter, that is called temperature, and always you need to maintain temperature of the space or product lower than the atmosphere. It is called refrigeration. So refrigeration is the process of controlling the temperature of the space or product lower than atmosphere. It is called refrigeration, right? Whereas air conditioning, so air conditioning is the process of conditioning of air by means of controlling 4 parameters. One is temperature, humidity. Humidity means the water vapor present in the air. Water vapor present in the air is called as humidity. Air velocity and air purity. So any machine able to control these 4 parameters like temperature, humidity, velocity and purity, it is said to be air conditioning. So in air conditioning we need to take in care of 4 parameters: temperature, humidity, velocity, purity. Whereas in case of refrigeration we are focusing only one parameter, that is called temperature, and always the temperature of the space or product to be lower than outside or lower than atmosphere, ambient conditions, surroundings, whatever it may be. So you need to maintain lower temperature. It is called refrigeration. right? So refrigeration is a process of maintain and control the temperature of the product or space lower than atmosphere. It is called refrigeration. That is definition. So what is the need of refrigeration? Next question is, what is the need of refrigeration? So the primary need of refrigeration is to preserve perishable products for longer period. Preserve means storage. Perishable means easily spoiled. The life of the product is small, it is considered as perishable product. We are having n number of examples for perishable products. All the fruits, vegetables, non-veg food items like seafood materials, fish, meat, chicken, all these are perishable. For example, if you take chicken or meat, or if you take milk, the life period may be 6 hours, or you can extend to 7 hours. It depends on atmospheric conditions. Generally, it is 6 hours. If you are not consuming the milk more than 6 hours, if it is open to atmosphere, then it is contaminated by the bacteria, virus present in the atmospheric air. If the same milk is kept in refrigerator, then after 2 days you can consume, because it does not spoil its characteristics, it does not lose its freshness. Similarly, if you purchase 100 kgs of tomato, but you require every day half kg or 1 kg, then if it is open to atmosphere, automatically after 3 to 4 days, all the tomatoes will be contaminated by the bacteria. You can found the outer surface of the tomato fruit will contain dark spots, that is, it is spoiled one, right? So always you need to preserve these products so that its life can be extended. For that we require refrigeration. Not only these products, there are some products which are available in season of the year. For example, if you take mango, tamarind, red chilli, these are summer season products. These are only produced or available only in the summer season. But if you see the utility, if you see the consumption of these products, it is throughout the year. The products will be consumed throughout the year, like tamarind, which is used in food items, or mango, it is a fruit. If it is available in winter season, we can consume, right? For that, we need to store these products in controlled environment with the help of cold storages, so that wherever there is a demand, we can retrieve from the cold storages. So refrigeration is used to preserve the perishable products so that we can increase the life of the product. Then well-defined applications of refrigeration. There will be many applications of refrigeration. I have listed on the slide here. Look at here. So there will be many applications of refrigeration. So one is manufacturing of ice. So in the outside environment, water is available. If you want to make ice, so we need to remove heat from the water, so the temperature of water reduces from room temperature to 0 degrees centigrade. Once it reaches 0 degrees centigrade, it becomes ice. How to remove heat? So by using refrigeration. So while manufacturing of ice, we require refrigeration. That is one application. And the biggest application of refrigeration is air conditioning. So air conditioning of domestic houses, restaurants, malls, banks, whatever it may, we can write n number of applications. Corporate colleges, corporate offices, cinema theaters, hospitals. In all cases, we are using air conditioning. Air conditioning is one of the largest applications of refrigeration. Similarly, processing and manufacturing of various chemicals. Similarly, processing and manufacturing of various medicines, we require refrigeration. Medicines will be manufactured in the controlled environment, not open atmosphere. For that, we require refrigeration, right? Preservation of human parts like blood, eyes, heart, kidney. These are all preserved for longer period if you provide proper environment. That is done with the help of refrigeration. So in chemical industries, for separating liquefying gases, we require refrigeration. So heavy dams generally constructed over the rivers, the life period of dam may be 200 years, 300 years. So while construction of dam, you need to cool, because you need to increase the strength of the dam. It depends on cooling rate. So most of the cases we are using chilled air or chilled water for cooling of dams. Space related application like rockets, jets, preparation of rocket fuels. These are all some applications of refrigeration. I just now told. So application of refrigeration is preservation of perishable products. If you look at here, these are all vegetables, flowers, seafood materials, fruits. So if these products open to atmosphere, it may alive its freshness, its appearance, maybe 1 day or 2 day or maximum 3 day, if it is applicable to vegetables or flowers or sometimes fruits also. But beyond 3 days or 4 days, so it starts spoiling. So damage of vegetables or flowers, fruits will be occurring because of bacteria virus present in the atmosphere. If the same vegetables, flowers, fruits is kept in refrigerator, so it is not contaminated by the bacteria. So that is the purpose of refrigeration. Similarly, seafood materials, if you take, so it may be available fresh, maybe 6 to 7 hours, right? Beyond 6 hours, so always it is contaminated by the bacteria. For that, you need to store these seafood materials in the refrigerator below 0 degrees centigrade, so that the entire flesh of the seafood will be frozen, so it becomes solidified. So solid state of any product is does not contaminate by the bacteria. Then let us see one important terminology. It is called turn-off refrigeration. It is called as turn-off refrigeration. The capacity of any refrigerator, is expressed by a term called as TOR. TOR stands for turn-off refrigeration. In general, turn indicates mass transfer, right? In general way, ton means mass transfer, which is equal to 1000 kg, which is equal to 1000 kg. But in refrigeration, ton does not indicate heat transfer, but does not indicate mass transfer, but it indicates heat transfer, right? Ton of refrigeration indicates rate of energy transfer. What is ton? It is defined the amount of heat removed from 1000 kg of water to make 1000 kg of ice at 0 degree centigrade within 24 hours. Then it is said to be 1 ton machine or 1 ton refrigerator, right? It is the quantity of heat removed from the 1000 kg of water at 0 degree centigrade to make 1000 kg of ice at 0 degree centigrade within 24 hours. It is said to be 1 ton machine. Mathematically we can express, if you are taking 1000 kg of water to convert 1000 kg of ice. So before moving that, you need to know latent heat. This is important. If you want to convert 1 kg of water into 1 kg of ice, whatever the amount of heat removed from the water, it is considered as latent heat, right? If you remove heat from the water, then the temperature of water goes on decreases. When it becomes 0 degree centigrade, then there is a phase change occur. Then liquid becomes solid. Solid state of water is called as ice, right? If you want to convert 1 kg of water into 1 kg of ice, you need to remove certain amount of heat, which is equal to 336 kilojoule per kg. 336 kilojoule per kg. The amount of heat removed from water so that the water becomes ice, it is called as 336. That means if you want to make ice from water, so you need to remove 336. I consider 1000 kg of water, then 1000 into 336 divided by the entire heat removal process from water to make ice taking place in a day period. Day means 24 hours. So 24, 1 hour equal 60 minutes. 60, so it is equal to 233.3 kilojoule per minute. Kilojoule per minute, right? So it is equal to 233 kilojoule per minute, and this value as rounded as 210 kilojoule per minute for simple conversion from one unit to another unit, right? The actual value of ton of refrigeration is equivalent to 233.3 kilojoule per minute, but it is rounded as 210 kilojoule per minute. for a simple conversion from one unit to another unit. If it is 210 kilojoule per minute, right, if it is 210 kilojoule per minute, then divided by 60, if I divide it by 60, so 210 by 60, then it is 3.5 kilojoule. It is kilojoule per minute. If I divide it by 60, then it is kilojoule per second. We know joule per second. What is joule per second? It is called watt. So 3.5 kilowatts. 3.5 kilowatts. So 1 ton of refrigeration equal to 210 kilojoule per minute or 3.5 kilowatt. 3.5 kilowatts. And we already know 1 calorie equal to 4.2 joules. 1 calorie equal to 4.2 joules. If I need 1 joule equal to how many calories? It is 1 by 4.2 calories, right? 1 by 4.2 joules. Then you can write 210 kilojoule per minute. What is joule? It is equal to 1 by 4.2 calories. So it is 210 by 4.2. It is kilo calorie per minute. If you simplify, it is 50 kilo calorie per minute. So ton of refrigeration can be expressed in various values. It is equal to 210 kilojoule per minute. If you divide it by 60, because 1 minute equal to 60 seconds, it is 3.5 kilowatts. Or since 1 calorie equal to 4.2 joules, so 210 by 4.2, it gives 50 kilocalorie per minute. So the meaning is the machine able to remove 2 ton kilojoules of energy for each minute. It is called as 1 ton refrigerator or 1 ton air conditioner, right? So unit of refrigerator is ton of refrigeration.